Hello students, we are solving the IB Math EA AGIL past paper questions and currently we are solving the IB Math EA AGIL May 2023 paper 2 times 1 past paper. Today we will be solving the question number 12, that is the last question of this paper. You will be getting the links to all the previously solved questions of this paper and of the other papers in form of playlist in my channel NS Online Math Tutoring Classes. So without any further delay, let us start answering question number 12. The maximum mark is 21. It says consider the differential equation dy by dx equal to x square y minus y over x square plus 1, where y is greater than 0 and y equal to 3 when x equal to 0. These are the two x and y values given to us. These are the initial x and y values. Okay. Subpart ES question. Use Euler's method with a step length of 0.03 to find an approximate value of y, because Euler's method will always be giving us only an approximate value of y when x equal to 0.15. Give your answer correct to 6 significant figures. The question is containing 4 marks. Okay. So it is the step length is h. H is equal to 0.03. Okay, and we are having the two equations for the Euler's method. It is there in the formula booklet, you can check. But I am writing this as, it is written as xn plus 1 equal to xn and all. But I prefer writing this as the current value of x will be equal to the previous value of x plus the step length, that is h. Okay. In place of c, you can write n plus 1, and in place of p, you can write n. That is there in the formula booklet, but I write this as the current value of x will be equal to the previous value of x plus h. Okay. And the yc, the current value of y, or yn plus 1, this may be n plus 1 as well, equal to yp, that is n, plus h times dy by dx. Actually, we will be getting the numerical value of the dy by dx expression. For that, we should be knowing the x and y values. So, which x and y values should we be taking? We will be taking the previous value of x and the previous value of y. So, it is, we will be taking the previous value of x and the previous value of y. Okay. So these are the two equations that we will be using, and of course the h value is equal to 0.03. Now we have to use the calculator and we have to go to the spreadsheet. The column A will be containing all the x values and the column B will be containing all the y values. So I'm naming the column A as x and the column B as y. And now I will be storing the initial values of x and y. The initial value of x is 0 and the initial value of y is 3. So this is 0 and this is 3. Okay. Now we come to the A2 cell. We will be calculating the current value of x because the A column will be containing all the x values. So in the A2 cell, we will be storing the current value of x based on the previous value of x. What is the previous value of x? It is 0. Where is it stored? Because we will be entering the formula, because I can just write x c equal to xp plus h. xp, the previous value of x, is equal to 0. 0 plus 0.03 will be equal to 0.03. I can write the current x value as 0.03, but I will not be doing that. I'll be entering a formula. So a formula will always be starting with this equal to sign. And now where is the previous value of x stored? In the A1 cell. So I'll be writing A1 plus h. H is 0.03. Okay. Enter. You see, now the current value of x is stored in the A2 cell. And the A3 cell has got highlighted. Again, if I have to store, of course, I will be calculating the x value for this A3 cell. That will be the current value of x. And for this, which one will be the previous value of x? The A2 cell's value, that is 0.03. Okay. So instead of calculating manually, obviously we'll not be calculating manually. That is why we are taking the help of the calculator. So I'll be highlighting this A2 cell, and you see this plus sign is appearing. I'll be just dragging this plus sign down. You may drag to any number of cells you like, miss. You may include more number of cells, no harm in that. You need the final value of x as 0.15. Okay. See, I have got the final value of x as 0.24. I don't need x value as 0.24. I need only up to x value as 0.15. I have included more number of cells. There is absolutely no harm in that. Okay. Now we come to the B2 cell. We will be calculating the present value of, or the current value of y based on the previous value of y. What is the previous value of y? It is 3. And of course, we will be needing the previous value of x as well. What is the equation or the expression? Yc equal to yp plus h times dy by dx, this expression, and it will be having the xp in place of x. We will be taking the previous value of x, and in place of y, we will be taking the previous value of y. Okay. So again, we will be entering a formula equal to y n, or you can say yp. So that is stored in the B1 cell. So it is B1 plus h is 0.03 times this dy by dx expression. So let me open the bracket, and it has the numerator and the denominator. So this is this. Okay. And it is x square y. So we have to take the previous value of x. Where is it stored? In the A1 cell. Okay. So I'll be writing A1 square because it is x square. So it is A1 square times y. So times previous value of y is stored in the B1 cell minus y. So minus B1 again over x square. So previous value of y, x stored in the A1 cell square, x A1 square plus 1. Okay, and bracket closed and enter. So this is the current value of y, or present value of y. Similarly, we have to get the other y values. So I'm dragging this. Okay. And I need the y value corresponding to the x value equal to 0.15. Okay. But I cannot give the answer just this final y value. That is because it is containing 4 marks. So it is better to give the table. Okay. X and y. This is 0, 3, the initial values, and then 0.03, 0.06, 0.09, 0.12, and 0.15. Okay. For this, I remember this one, 2.91. Then I have to check. 2.8228 up. I'm giving the answers, the intermediate answers up to 3 significant figures. Okay. So it is 2.82. And then the next one is 2.74. Next is 2.66. Okay, because it is 2.657. So it is 2.66. And then the final one. Okay, it is 2.58046. 2.580.6 0.046. 2.58046. Now, if you are not sure, because they have displayed only 6 digits, and the question is saying we have to give the answer correct up to 6 significant figures. So we are not sure of what will be the next digit. In that case, you can just copy this. Just copy this one. I want just this one. Okay, Control C. And I come to the calculator page and I'm doing Control V. I could have used this keypad also. You see, now we have got the entire value. What is the next digit after 2.580.6 It is just 1. So the answer that they have displayed is correct to six significant figures. Okay, if you are not sure, this is a better way of testing whether the answer that they have displayed is correct to six significant figures or not. Okay, just copy that and bring to the calculator page, and if you paste it, you will be getting all the digits. Okay, so this will be the answer actually. So the y's value, and again it is an approximate value, so I am using this symbol. It is 2.58046, correct to six significant figures. When x equal to 0.15. Okay, so this is the answer for the subpart A. Coming to the subpart B, write down the value of dy by dx when x equal to 0. Okay, I dy by dx when x equal to 0 equal to 0 squared times when x equal to 0, y equal to 3. Okay, so x square y, 0 squared times 3 minus 3 over 0 squared plus 1 equal to 0 squared times 3 is 0 minus 3, and the denominator is equal to 1, so it is minus 3. Fine, and then I, it is show that d2y by dx square, the second derivative equal to 3 when x equal to 0. Fine, so d2y by dx square, first of all we have to get the expression. Therefore, we have to differentiate this expression. Okay, so it is, I'm using the quotient rule. X square plus 1 whole square, and then I have to differentiate the numerator, which is this one will again be needing the product rule. So it is 2xy minus, not minus, sorry, plus x square and dy by dx. Derivative of y with respect to x is dy by dx minus y, so it is minus dy by dx the denominator is x square plus 1 minus the derivative of the denominator x square plus 1. Okay, first of all, let me write the numerator. X square y minus y, and the derivative of the denominator is just 2x. Okay, so d2y by dx square when x equal to 0 is equal to 2 times 0 times when x equal to 0, y was equal to 3 plus 0 square dy by dx when x equal to 0 is negative 3. Okay, don't try to input the expression for dy by dx over here. Okay, it will be a long lengthy expression. Okay, the answer, ultimately the answer that you will be getting the same provided you do the calculation correctly, but you don't need that. Dy by dx value is negative 3 when x equal to 0, so I am substituting negative 3 in place of dy by dx, and minus of minus 3, and this is 0 square plus 1 minus 0 square times 3 minus 3 times 2 times 0. Zero square plus 1 whole square. So this is equal to 2 times 0 times 3 is 0. 0 square times negative 3 is also 0. And negative of negative 3 is positive 3. And this is 0 square plus 1 is 1. So 3 times 1 is 3. And this one is multiplied by 0. So it is 0 over 1, which is equal to 3. Okay. So we have got 5 marks so fast. Subpart C, it is containing 2 further subpart. The I's question is given that d3y by dx cube equal to 9 when x equal to 0. Find the first 4 terms of the Maclaurin series for y. Okay, so Ci, and these are the values y equal to 3 when x equal to 0. These are the two x and y initial values given in the question when we were solving this differential equation using the Euler's method. And dy by dx, we had found the value as negative 3 when x was equal to 0. And d2y by dx square, we have shown this value to be equal to 3 when x is equal to 0. Okay. Now, the Maclaurin series for y will be y is equal to y of 0 plus x y dash 0 dy by dx, I'm writing it as y dash 0 plus x square over factorial 2 y double dash 0 plus x cube over factorial 3 y triple dash 0. Of course, plus dot dot dot. I have written just the first 4 terms. Okay. Now I will be substituting the values. Y of 0 is equal to 3 plus x times, that is negative 3. This one plus x square over factorial 2 is 2. Double dash, it is 3. Plus x cube over factorial 3 is 6. Triple dash, this is 9. Plus dot dot dot. Okay. So this is y equal to 3 minus 3x plus 3 over 2. You can keep it as 3 over 2 or you can write it as 1.5, up to you. X square, and this is also 3 over 2. 3 times 3 is 9 and 3 times 2 is 6. So this is plus 1.5 x cube and so on. So this is the answer for the subpart I. I use the Maclaurin series to find an approximate value for y when x equal to 0.15. Give your answer correct to 6 significant figures. Okay. So y of 0.15 will be equal to 3 minus 3 times 0.15 plus 1.5 times 0.15 whole square plus 1.5 times 0.15 to the power of 3 plus dot dot dot, of course. Therefore, y 0.15 equal to 3 minus 3 times 0.15 plus 1.5 times 0.15 square plus 1.5 times 0.15 to the power of 3. Okay. So enter. Fine. 1, 2, 3, 4, 5, 6, 7, 8. Fine. So up to 6 significant figures, we have to give the answer up to 6 significant figures. So it will be 2.5 and then up to 1. 2.58881. Okay. 2.58881. Correct? 2. Correct to 6 significant figures. Okay. Fine, we have given the answer for subpart C. Subpart D, it is again containing 2 further subparts. The DI is saying it is given that x squared minus y 1 over x squared plus 1 is equivalent to 1 minus 2 over x squared plus 1. Solve the differential equation dy by dx equal to x squared y minus y over x squared plus 1 where y is greater than 0 and y equal to 3 when x equal to 0, and give your answer in the form of y equal to f of x. Di. I'll be using the separation of variables method. So dy by dx is equal to y and x square minus 1 over x square plus 1. Okay. So this gives us dy over y equal to x square minus 1 over x square plus 1 dx. And now we will be integrating both sides. Okay. And this can be written as x square minus 1 over x square plus 1 is equal to 1 minus 2 over x square plus 1. Okay. So this can be written as 1 minus 2 over x square plus 1 dx. Okay. Therefore, this is ln of y. And if I just separate this, integration of 1 dx is x minus integration of 2 over x square plus 1 with respect to x will be minus 2. What is the integration of 1 over 1 plus x square? It is arctan of x. So the 2 is the coefficient. So I have taken that minus 2 outside and it is arctan of x plus c. In order to get the value of this c, we will be needing this information. So ln of y, ln of 3, it is a positive value. So I'm not using the absolute notation anymore. And x equal to 0, minus 2. And arctan of 0 is what? 0. Arctan is tan inverse. Tan inverse of 0, tan of 0 is 0. Okay. So arctan of 0 is 0 plus c. Therefore, c is equal to ln of 3. Therefore, ln of y is equal to x minus 2 arctan of x plus ln of 3. In place of c, I am writing ln of 3. Okay. And they are asking us to give the answer in the form of y equal to f of x. So therefore, I can write, therefore, y is equal to, I am changing to exponential form. It is e to the power of x minus 2 arctan of x plus ln of 3. Now you can separate this part if you want, and you can write this as e to the power of x minus 2 arctan of x times e to the power of ln of 3, and e to the power of ln of 3 will be equal to 3. So this is equal to 3 e to the power of x minus 2 arctan of x. Okay, so this will be the answer for the D, I. Okay, of course, y equal to this. And then it is I. Hence, find the value of y when x equal to 0.15. So, y equal to 3 times e to the power of 0.15 minus 2 arctan of 0.15. Okay, so this should be equal to what? Let us find out. 3 times e to the power of 0.15 minus, let me put a bracket first of all, 0.15 minus 2 times arctan, that is tan inverse of 0.15. Okay, enter. 2.58 up to 6 significant figures, most probably, right? Yeah. 2.58786. So 1, 2, 3, 4, 5, 6. And the next one is 2. So I'll be writing 2.58786. Okay. 2.58786. Correct to 6 significant figures. Okay. Now the subpart E, for x greater than or equal to 0 but less than 1, explain why the approximate value for y obtained using Euler's method will always be less than the actual value for y. Using the Euler's method, we had found the value of y when x was equal to 0.15, which is in this range. X is greater than or equal to 0 but is less than 1, as 2.58046. Whereas the actual value of y is 2.58786. So obviously 2.58786 is more than 2.58046. This is a particular y value for x value equal to 0.15, but they are saying that for this range of x values from 0 to 1, less than 1, y value obtained using the Euler's method will always be less than the actual y value. Euler's method will always be giving us an approximate value of y, but it can be more than the actual y value as well. Why is it less than, always less than the actual y value? Actually, it is always related to the concavity of the function. Okay, and now that we have come to know about the function expression, y is equal to 3 times x e to the power of x minus 2 arctan of x. Let us graph, this is paper 2, we can take the help of the calculator. Let us graph this expression, okay? So, let us graph, okay, and it is 3 times e to the power of x minus 2 arctan of x. X minus 2 times arctan of x. Okay. We are seeing between 0 and 1 they have said. So let us just take the x min as say -1 and x min as say 1.2, or I can take this as negative 0.2. I need the range between 0 and 1. Okay. So, fine. So, this is the portion that we are seeing. And now you can see the concavity, it is clearly concave up. Okay. It is clearly concave up between this 0 and 1. It is clearly concave up. Okay. So, we can write using GDC graphs. We find y equal to, find the graph of y equal to 3 e to the power of x minus arctan of x is concave up in the region okay. Therefore, you can draw the graph if you want, or if you feel that you don't have time, you may skip this portion as well. It is just a rough sketch. Okay. I don't know what is the corresponding y values. What is the y-intercept? I have no idea about that, but it is somewhere of this shape. Okay. And now you see, if it is concave up, then if you want to draw a tangent over here, let me try to draw a tangent at this point. So if I take this point and if I draw a tangent over here, okay, you see, what are we doing in Euler's method? We are taking an initial point and we are getting the x and the y values for this point. And then we are just dy by dx is what? It is the tangent, gradient of the tangent. It is not the tangent actually, it is the gradient of the tangent. Then we are just going to the next point of this tangent line by adding the step length. So I will be coming to this maybe over here, but the original graph is moving up. But I am coming to this point because I am moving along the tangent line. Okay. And the tangent line we are seeing is below the curve. And as it is moving in this direction, the curve is moving in this direction because it is concave up. But the tangent line is moving in this direction. It is a straight line. And we are repeatedly taking points from that tangent line. The tangent line that we have considered at the very beginning. We are just taking different points from that tangent line by using the step length. We are adding the step lengths. That is why as we are moving further from the initial point, the value of the y obtained from the Euler's method will be going on decreasing, and the difference between the actual value of y and the value of y found using the Euler's method, the difference will go on increasing because the curve is moving up and the tangent is a straight line. It is just moving in a straight single direction. Okay. So that is the reason. We may write, since the graph is concave up, the distance between the graph, the function graph, and the tangent goes on increasing. the tangent goes on increasing. So the tangent is always below the curve. Okay. Therefore, the y values on the tangent on the points or of the points, sorry, on the tangent will be smaller than the actual y values of the points on the curve for the same x value. Okay, same x values. Okay, fine. So this is the explanation. And we have completed answering this question. Thank you for staying with me till the end. I am Nilanjana Sanyal. I am an online IB Math ASL and HL level tutor, and I tutor students from both within India and outside India. And I offer both one-on-one and small group online tutoring services to my students. In case you are liking my explanations, please to give this video a like and please to share this video with your friends so that even they can get benefited by watching my videos. And in case you have not subscribed to my YouTube channel, please to subscribe to my YouTube channel. It will be motivating me to make more math videos for you. And in case you are having any question, any confusion, please feel free to write to me in the comment section. I'll be trying to solve your confusions, your doubts. I'll be trying to answer your questions as much as possible. We meet again very soon in our next session. We'll be starting a new paper. So till then, bye.